Okay, let's review. So natural log has two definitions. What is natural log? It's the area underneath a rational function starting at 1. Remember that? How we counted up the area with like the tiny little boxes with 1/100th each box?
Yeah.
It's also just a logarithm with base e. Okay? The base is e. What's the value of e? 2.7. 1/8. ln of e is 1. That's good. Yeah, ln of e is 1.
Wait, that's 2.7?
1/8.
E is 2.718. So just like you know pi is 3.14, e is 2.718.
Yeah.
So if you were to look at a graph of ln, you would see the point, where's my graph of ln? Like, see here, like look at this graph. See how, let me zoom in here. See this graph of ln. See how at 2.7, right here, see this point? 2.7 comma 1?
Yeah.
So like e is on the graph. Okay, check. All right, let's, so this whole class we're gonna do practice problems, and we should, we'll probably close the book on practicing today and move on next class. What's the formula for the derivative of ln of x? Or ln of u? 1 over.
1 over x.
Yeah, it's 1 over x, but
Times the derivative
Of u.
of the inside.
yes, times the derivative of the inside, because we almost always have to use the chain rule, right? So recall this slide.
This, yeah.
The derivative of ln of u is 1 over u du.
1 over u du.
Yep.
Times the u.
Yeah, so 1 over the argument times the derivative of the argument.
So that's what we're using to solve it.
That's what we're using. All right, let's do this problem, okay? So find the relative extrema. Find the relative extrema. Okay, so I have 2 steps. Step 1, critical points. Take the derivative, set it equals 0, and do any. Step 2, number lines. Go, take the derivative. 1 over u, which is x squared plus 3x plus 2. All of that is u.
This one goes
Well, anyway,
Oh, 2.
because then you can just do 2x. You do this whole.
Okay, that is 1 over u du. I can simplify this and put this in the numerator, which I'm going to do. 2x plus 3 over x squared plus 3x plus 2. So that's the derivative. Not too bad, yeah? Yeah, okay. So I set the derivative equal to
0.
0
And the
and dna. All right, I'll let you catch up writing.
No, I'm just rewriting it later. Okay.
You're a soldier.
Okay, where is this, where's f prime equal to 0?
The numerator.
Yeah. So something's equal to 0 when its numerator is equal to 0. Where is this function equal to dne?
The denominator.
The denominator is equal to 0. You don't do many examples where they're fractions, rational functions, we call this. Yeah, so a function, so the function's dne when the denominator is 0.
Oh!
Yeah, so that's what I just did. Okay, so this one, I'm going to solve them real quick. X equals negative 3x. This would be x plus 2 times x plus 1 equals 0. X equals negative 1 and negative 2.
That's it?
That's step
number
one.
line.
Number line, yeah. What are these three numbers called, by the way? We have a vocabulary for them. Candidates. 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 So these are my candidates. We're going to put them all up for election. The number line is going to be the voting mechanism. And we're going to see who ends up being a relative min, a relative max, or maybe neither. Right?
So these
Yes.
are critical points?
They're also called, critical points. There are critical points too. Yeah.
Because I thought the candidates were when it's like absolute max.
So those we also call candidates. Yeah. Yeah. You're right. Critical points is perfect. They are critical points. Okay, you ready to make your number line?
Yes.
Okay, go. Wait, actually pause. Before you write your number line, I'm going to rewrite this. It's going to be easier to sub this in factored form. Okay? Because I like plugging this in factored form. So I would rewrite this as 2x plus 3 over x plus 2 times x plus 1. Okay? It'll just make the substituting in to get your positives and negatives on the number line easier. Okay, now I'll let you go and do the number line. Yeah. All right, let's do a little bit of plugging in together. So this is a negative.
Oh, I need to pick one.
So I'm going to plug in a number in between here. All right? You listening?
Yes, ma'am.
Okay. So I'm not even going to name it, but I'm just going to plug in between there. Negative 1.75 would be good. But this is bigger than, like, the numerator is going to be negative. Does that make sense? Okay, and then the denominator, if it's in between here, this is going to be positive, like the 2 is going to overpower it. And here, the negative that I plug in is going to overpower the 1. Does that make sense?
Yeah.
So negative
Wait, but what-
over negative is the positive?
Yes.
What do we have to solve for that? Like,
Yes. Because when f prime changes signs, it's going to be a min or max. All right, this is a negative and this is a positive. All right, so x equals negative 2. Let's answer the question. X equals negative 2 is a relative min. You could also say local minimum. It did not ask for the justification, but what would the justification be?
Because f prime changes from negative to positive.
Yeah.
So negative is no positive.
Okay. Okay, what about negative 3 halves? Yep. Because f prime changes from positive to negative.
Wait, what is the natural log have to do with it?
Well, this is my original function. But for all these relative min and max problems, like you only use the function in the first step and then you never use it again. This is different from absolute mins and max, you plug into the original.
Yeah.
But the only thing you do is use this to take its derivative. And then you don't use it for the rest of the problem. Okay, and x equals negative 1 is a relative min. All right, let's do some APQs.
Let's go.
So these I could have put on a classwork, but I want to have everything in one place. Yeah, we're going to skip the next slide. It's okay. All right, ABQ 3.
We're skipping that.
Yeah, we're skipping that. Okay. What? Look at this. Look at this. ABQ 3. So my function is y equals ln of x over x. What rule? Don't shout it out. Just think in your head. Just think. What rule am I gonna have to use? Think. What rule am I gonna have to use? Like an old rule. Like not that I learned, not from this packet. Quotient rule. Yes. Lord knows thing too. Okay. So set up the quotient rule. Low D low, high D high, all that.
Low D.
It's low D high. Yep.
Low D high.
Minus high D low.
Over low squared.
Yes. Low D high minus high D low over low squared. Okay, so this is my low D high minus high D low. So you get x times 1 over x is 1. So it's x over x is 1 minus ln of x over x squared is d. All right, you ready to move on?
Yeah.
All right, ABQ 4. Same thing. What rule am I thinking? Product rule, because there's multiplication and there's an x in multiple places. All right, so set up the product rule, udv plus vdu.
Would x go in the first thing?
Yep, x is u. Yep,
And then L of x, which is,
ln of x squared.
isn't that like the chain? No.
All right, so this is my udv plus vdu. So I get x times 2 over x plus ln of x squared times by 1. This is 2x over x. You get 2.
Yeah. Yeah. Oh,
So in other words, it's like 2x over x. You multiply the numerators,
And then you
multiply,
can.
and then you can cancel the x's.
Yes. Okay.
Which is b. B. I want to remind us of a pattern.
it should be 2x over x.
You simplify it
Oh,
over.
you should, okay, I didn't do that. I simplified it.
Okay. Reminding, look at this slide. We did this before. Remind us of this pattern.
Yeah.
So remember how the derivative of ln of x squared is 2 over, Tamara, remember this pattern? So we could do this out every time. That's not a problem, but the derivative of ln of x squared is 2 over x. Derivative of ln of x cubed is 3 over x. Ln of x fourth is 4 over x. Because we could also use the power rule to rewrite this. We could think of this as the derivative of, put that out in front, 2 ln of x. Yes?
Yeah.
Yeah. Which would be 2 times 1 over x, which is 2 over x. Okay?
Wait, ln of x equals 1 over x?
No, that's the derivative. The derivative of ln of x is 1 over x. So that's what that d dx is about. It means like derivative equals this. And then look on the left just to remind yourselves, if there's a constant, it doesn't make a difference. Just like little tips. All right, let us go back to the next slide. APQ, oh, APQ 5?
Sure.
Yeah, love it. What rule are we thinking? That is the chain rule. Because ln of x is inside, there's like an inside.
And it doesn't equal 1.
Yes. So in other words, this is like, so this is my f, this is my g. So the derivative is f prime of g of x times g prime of x. Remember that?
What was the derivative of just ln?
I'll let you try it.
Okay.
Try it on your own first. We'll see what happens. Video. So this is the derivative. This is my u. So the derivative of ln inside is ln of u. Yeah, which is,
1 over x.
yep. Good. So what is the answer?
Oh, I got that. No, I didn't.
It's e.
It is e.
Wait,
Turn that by some
I
time.
feel like I wrote out way too many steps.
Yeah, you're
Here,
in
I like
Yep.
made it way too long. Is that the derivative of ln was 1 over u times du?
Yeah, yeah,
No.
that's fine. That's true.
How would I solve from there?
But like the u is just x. So 1 over x times the derivative of x, which is 1. Does that make sense?
Yeah, I think so.
Yeah.
That's what I'm getting.
Okay.
Into this internship, he was dressed so.
Alrighty, what about this one? Alright, we're gonna use, this is just, there's no special rule, it's just gonna be like a little bit tricky, but algebraically. 1 over u du is all you're gonna use. So this is my u, right? So 1 over u du. Try it. You'll have to do some simplification after your first step to get the answer. No.
Okay.
Okay, du. Okay, alright, so my u is 1 over 1 minus x. So first of all, you want to like rewrite this, yeah?
Yeah.
So you multiply by the reciprocal of the denominator, it's just like a double flip, so this is going to be 1 minus x. That's like how this simplifies.
Okay.
So 1 over something is just a something. I can
It's
show out the
just a
steps,
something?
but it's just a something.
So, right?
This, to take the derivative of this, I need to rewrite it first. I need to do 1 minus x to the negative 1. I'm going to differentiate it
Y to the negative 1.
because I took it out of the denominator. This is tricky.
You can't do the quotient rule on that?
Oh, sure. Do you want to use the quotient rule instead?
We can do either way.
Can you show us this way first?
Yeah.
Because I know the quotient rule.
Negative 1, 1 minus x to the negative 2. We could have totally used the quotient rule though. Actually, that might have been easier.
Well,
We'll do this anyway. So is this, are we in agreement? Times by, what's the derivative inside? We totally should use the quotient rule.
So that makes
Forward
it
committed.
1 over.
See how this is the derivative inside? Right?
yeah.
Chain rule.
Yeah. So that makes it 1 over like 1 over 1 minus x squared.
And then negative make a positive, so go away.
Wait, can we do the quotient rule of this way?
Yeah, let's do the quotient rule really quick. Low, 1 minus x, negative 1. High is 1, the derivative is 0.
Yeah, so this
So low d high, 0, minus high d low, negative 1, over low squared. So positive 1 over 1 minus x squared.
that's why I said it's
Which is
du,
what we got.
because I didn't put it over 1 minus x squared.
Ah,
Also, wait,
so
how do
1,
you,
yep.
how do you simplify 1 over 1 minus 1 over 1 over 1 minus, right?
Yeah, so, okay, if you have a complex fraction, the rule is as follows. Multiply by the reciprocal of the denominator over itself. So technically, you know how like multiplying by a form of 1 doesn't change things? So I'm going to explain this conceptually, but it'll be better. Even if the bell rings, we'll stay for like 1 minute.
Okay.
Okay? So, multiplying, I need to multiply by a form of 1. That's what I always do, right? So I'm going to multiply by 1 minus x over 1 over 1 minus x over 1. Remember, this is a form of 1, so I'm not changing it. So I take the reciprocal of the denominator and I put it over itself.
Not negative though.
No, not negative, just the reciprocal of the denominator. This, let me get another color going on. This can't, like, divides to 1, cancels.
You're aware.
That divides to 1, cancels. So this is why my denominator goes away, because it's a 1. See how this whole thing is a 1?
Yeah.
That's why I did it, because multiplying by the reciprocal makes 1, and I want 1 in the denominator to make no denominator.
I was thinking perpendicular.
Okay. And then this is just 1 minus x.
Right on.
Okay.
So you multiply by the reciprocal of the denominator over itself.
So.
Oh, wait, let's do the answer, yeah? Wait, pause, so I have 1 minus x times 1 over 1 minus x squared.
One over.
So this is to the first power. Let's write it out. So I have 1 minus x over 1 minus x squared, right?
And we
One over
simplify
one
it, so it's
minus
A.
x. Yeah.
Okay.
That was so complicated just to get that.
Also,
Yeah, it was so complicated.
explains
All right, as you're packing up,
New things.
tell your neighbor something you learned today or just remembered about Ellen. Tell him something you learned.